Hello, everybody. Let me see if we can anybody hear me? Thank you. Anybody?
Yeah.
Thank you. Thank you. That's always the first thing because I never know when my computer's muted. Hey guys, we're gonna get started right away. I already started the recording. We're gonna start putting everything together with the quadratics. So we're gonna have just like 10, 15 minutes of notes, and then I'm gonna get you guys on your Khan Academy. So let's go back in time, back in the day when you were able to solve this. All right, this is called flashback. Flashback. How do you solve this? How do you solve a linear equation? What do we do? We need to find out what what number to put in x that'll make the equation equal 0. Remember, like in 7th grade, maybe even 6th grade, they started doing this. I would say 7th for sure. You want your answer to say x equals at the end. You want this to say at the end. Anyway, well, you would add 3 to both sides, right? And then you would cancel that out, and that would equal 3. And then you would divide by 2, or you would think, what times 2 is 3? You say, 1.5. So then you would say x equals 1.5. That was nice. It was easy, right? There's one answer. All right. So now we have quadratics. And I'm going to pick one, and I'm going to do it in, let's do it in, we have 3 options, factored form, standard form, and the other one. Which one would anybody like to do? Which of the 3 would you like to do first? We have 3 options now. So would you like to solve one that's factored looking, one that's in standard form, or one that's in vertex form? I need somebody to pick one. I don't care who. You can even type it on the chat. Doesn't matter. Let's see. Getting a lot of no participation today. All right, let's do standard. All right, thank you, Stephen. All right, here's a standard form equation. Now, this is not a function, but it's going to look like a function, but it's going to be, it's just an equation, okay? And this is going to be x squared minus 5x minus 6 equals 0. So this is different. This is different than this because, and let's do it the wrong way. Let's say we did our old technology. We'd added 6, and then we have you'd have x squared minus 5x equals 6. And then you're like, shoot, I need to get x by itself. So maybe I could divide everything by x, divided by x, divided by x, divided by x. And then that turns into x minus 5 equals 6 divided by x. Oh, dang, the x popped over here now. Anyway, so this doesn't work. Because then the x's just kind of like pop left and right. We can't actually get x by itself. So what we could do with this, you should definitely be writing this down, Hamar. I'll wait for you. So anyway, I wanted to show that this method doesn't work on quadratics, right? You can't just subtract, add 6 and then divide by x or divide by. You can't combine these right here because one's x squared, one's x. So what we can do, is we could try to factor this thing. So let's try to factor this. So we're going to use our box, right? And then hopefully we can get something to look like this. So two numbers equal -5, right? When you add them. And the same two numbers, when you multiply them, they equal -6. So what two numbers multiply to -6 and also add into 5? Let's see. I don't know. I'm just going to guess. Let's see. 2 times -3 does multiply to -6, but 2 plus -3 does not equal -5. So that doesn't work. Okay, so that doesn't work. So I'm going to cancel that.
Well, one idea I think, well, we could do like.
So yeah, think about what two numbers multiply to -6.
Multiply to -6 and add to -5. Okay. Hold on, I'm gonna need an idea.
Yeah.
I was thinking 5 and 1 like in like different forms, like
Yeah.
-1 positive. But
so 2 and 3.
I forgot the correct one.
Right? That does that. So that does multiply to -6, right? What other two numbers multiply to -6?
Oh, it's supposed to be multiplied.
Yeah.
I was kind of getting the idea of multiplying to -5 and adding it to -6.
Oh, no. Yeah, it has to be, it's got to be that way. It's got to be multiplying to this one, right? This is the multiplying part. And this is the, think of like the number times 1. Does any number times 1 equal the same number? So
all numbers times 1 are the same number.
Yeah. So how about -6 times 1? Does that equal -6?
Let me go calculate that.
And then what about -6 plus 1? Does that equal -5? So this works, and so does this work. Therefore, this is going to be -6x, and this is going to be 1x. Because these two, when you add them together, it equals -5. And if you put -6 here and 1, that equals 6. I'm going to put this in this blue. It's that one right there, -6. And then this x squared goes here, x, and that's this one right here. So this is going to be x minus 6 times x plus 1. So if this was a function, what would your x-intercepts would be? What number would make this become 0? What number can you put in here that's going to cancel out -6? What number would cancel out -6 right here? So the opposite would cancel 6, would be 6. And then what number would cancel out +1? So here is the two answers. How would you prove that it's true? Like, how would you prove that if you plugged in one of them, it would get it becomes 0, the whole thing. All right, you could plug them in. Travis, which one would you like to plug in? The 6, the 6 or the -1? It's supposed to be -1, guys. Which one you want to test out?
That's 6.
All right, let's test it out. So we're going to plug in 6 for x. So we're going to put 6 squared minus 5 times 6 minus 6 equals 0, right? So this is going to be 36 minus 30 minus 6 equals 0. 36 minus 36. So 0 equals 0. It checks. It works. So 6 worked. All right. And the other number we tried was -1. So I'm going to put -1 in the parentheses. All right, this becomes 1 plus 5 minus 6. 6 minus 6 equals 0. 0 equals 0. That also worked. So -1 also worked. All right. So the idea here is that you're solving the equation, right? These are not x-intercepts. They're kind of like x-intercepts, but this is not a graph. This is not a graph. It's just an equation. But it looks kind of like it would be a graph, okay? All right, so there is no vertex for this. There's no x-intercept. There's just the answers that work, okay? So I'm gonna do one more, and then I'll have you guys practice a little bit, okay? Ask questions, guys. This is where it gets a little tricky. All right, let me see. Let me pick one. Remember, these are all going to be equations, okay? Here's another one. Let's see. Let me click on my scores. Manage. Okay, here's another one. I'm going to pick one from the actual computer. Give me a second while I load it up. Okay. All right. Come on, computer, hurry up. All right. Oh, this is easy. This is simple. X squared minus 2x plus 1 equals 0. Okay. So, first step, try to factor it, which means make the area model, right? And put the proper things in this. This one goes here. And then this one goes here. It's a positive 1, right? You don't really need the plus 1, but it's a positive 1. And then you're going to have your two numbers. Something plus something equals -2, right? And the same number times the same number equals +1, which is this one right here. All right. So what times what is 1 and also adds up to -2?
-1 and -1.
All right. So -1 plus -1 does equal -2. That works. And -1 times -1 does equal 1. So that works. That means these numbers go inside of here. Right? So these two numbers, they go inside. Okay. All right. Now you know what the outside is. I'm going to use, I don't know, blue for the outside. X minus 1, x minus 1. That means these are twins. X minus 1 times x minus 1 equals 0. So what number can you slide into x that's going to cancel out -1? What number will 1. So x must equal 1. And it's also the same thing here, so it's the same answer. There is two answers, but they're the same answer. So you could say they're just one answer, or you could say there's two answers, but they're the same, right?
So this isn't a function?
This is not a function. This is just an equation, right? Does that make sense? So an equation versus a function, it looks like this: x minus 1. All right, x minus 1 equals 0. And here is a function. So this one says x equals 1, and this would draw a parabola, right? This would actually, the function would actually draw a parabola, right? At x equals 1. And then it would have like the 1 over 1. Does that make sense? So there's like millions of points on a function. Versus an equation, what's not a graph? An equation is just an equation. It's like what number works, right? So this is a function, and this is an equation, right? So we're going to use the same like technique for both, okay? All right, so last one, and then we'll try it out, okay? 1 second. Let me get one from the computer. I can make them up, but I think the ones I make up will be harder than the ones. All right, here's the last one, guys and ladies. This is still an equation, not a function, but we're still going to like treat it like a function. All right, equals 0. So the question is, what number can go in here and here that will make everything become 0? So first step is try to factor it, right? And remember, the factoring is you're drawing the box, right? Little by little, you may not need to draw the box. Then you think of two numbers that add to -1. And I say -1 because there is right here is actually a 1, right? And the same two numbers multiply to -12. All right, guys, so thinking time. What two numbers multiply to -12 and at the same time add up to -1? Okay, so I'm going to put this -12 here. The -12 is going to be green. So what two numbers multiply to -12 and at the same time add up to -1?
-4 and 3.
-4 and okay, I was going to pick a different color. So there's a little bit of guessing and checking, right? I guess so. You're not often going to get on the first try. -4 and 3, -4 and 3. All right, does this work? Yes, yes. That means these go inside. Right, make sense? So once you finish the inside of the box, now you can do the outside of the box. This is kind of what I was saying. It's like riding a bicycle, but it's backwards, right? This would be x minus 4, and then x, and then 3. So therefore, this is the same thing. This is the same as that. Same thing. All right, so now this, we like this one because this is easy to find. This is easy, right? All right, so what number can we slide into x to get rid of this -4? So x must equal 4. Or we can slide a number in here and get rid of this -3. What number would get rid of that negative? I'm sorry, I already get the answer. What number would get rid of 3? -3. So these are the answers. So x equals 4 or -3. So that's the idea with this. Remember, these are not functions; these are just equations, but they're kind of like this would be your x-intercepts if it was a function. If
shouldn't it like be like x equals -4 or +3?
Yeah, that's a good question. So remember, if you have, let's pretend I have two numbers, and they become 0, right? When you multiply them, right? Does that make sense? So would you agree that one of them has to be 0? This has to be 0, or what?
Yeah.
Or this one's 0, right?
Sure, one of them.
One of them's got to be 0.
Yeah, one of them has to
So,
be 0, yeah.
How can you make this number become 0? Travis, what would you have to slide into the x to get rid of -4?
That's what I wasn't asking, right? I was just asking like whether or not the 4 should be a negative number and that the -3 should be a positive number, like a +3.
Yeah, so what I was saying is, if you have x minus 4, right, and this number has to equal 0, remember we said it has to equal 0? What number would you slip? Would you replace? What number would you put a -4 into x, or would you put a +4?
+4.
Exactly. So you would put a +4.
Oh, okay.
So you got to think of the number that would actually make this disappear, right? That makes sense?
All right.
Good question. Good job. All right. So this is kind of the same as we've been trying. Remember, factoring is, in my opinion, like the most complicated thing. All right. I'm going to give you, I said this was the last one. I'm going to give you one more just because I feel that we need more practice. Let me give you one that has a number in front of it, okay? Let me see. Let's see, what would I do? Let me look at my. Okay, here's coming right now. All right, this one is going to have an extra number in front. We need to get rid of that number, okay? All right, we have 2x squared minus 40x, and then plus 200. Plus 200 equals 0. Okay, so do you notice how all of the numbers are even? 2, -40, and 200? Well, I think it'd be a lot easier if we divided everything by 2, even the 0. And then we'd have a new, easier equation. X squared minus 20x minus 20, and then plus 100, right? Equals still 0, right? This 0 didn't change. All right, now we're going to try to factor, okay? All right, so we're going to start with this, right? That one. And then I'm gonna try to keep my colors coordinated. And then we have some number times another number. You already got it?
I think I already got an idea what the number is.
Yeah, let's see. Let me
for both.
Okay.
Both numbers.
All right, let me finish writing this out, and then what numbers do you think they are, Travis?
Both numbers being -10, like
-10, that works, right? -10, that also works. So therefore, you're actually finding out the numbers that go inside here. Like, this is the hard stuff, right? So that means that now that you're finished doing the inside of the box, now you get the outside. So you're going to have x minus 10 x minus 10 equals 0. So x has to be, Travis, is this answer going to be 10 or negative 10? What number can you slide into here that's going to get rid of negative 10?
10.
10. And it'll be the same number for both, right? So it's only going to be one answer. All right, guys, so the idea here is that if you have an extra number out here, you could try to get rid of it by dividing by that number. All right, so let's start the con. And I'm going to go ahead and go to Khan Academy. And what I want you to do first is the solving the intro. Let me look at okay, so yeah, do the intro. Yep, do the intro. I'll project it as you guys do it, and then ask me questions so that we can work together. And you might see one of the ones we've done, but try it out. Oh, well, you probably all have different ones, correct? Or we all have the same one? I think you have different questions. I selected different. Okay, so what I want you to do, and you should do it on paper, but this is the one we did over there. So this one goes here. And then this one goes here. And then something times something equals negative 12. And then something plus something. So we might take 2 days on this. I'm not 100% sure. So let's see how you guys do with this one. So the answers are 4 and negative.
What am I hearing in the background?
Oh, my wife's printing some stuff. Okay. When you put your answers, you got to put the smaller one first, which is the negative, or if the bigger negative. Okay. Like I said, you don't have to do it on the screen. It's actually a lot easier to do it on paper. Let's see. This is a nice, easy one. Something, and if you want to do an advanced one, you just do something times something equals 64, and something plus the same one is 16. Well, that's nice and easy. That's going to be 8. Right? So that's going to be x plus 8. So that means x equals negative 8. It's kind of like the opposite. Let me see how you guys are doing. I'll take a see. Let's see. All right, Nathan, good job. Nathan, try out check out the video that Khan did. He does it differently. He does it without the area model. And that's actually the way I know how to do it. The area model, I had to learn it for our school district wanted to teach that way, so I had to learn that one. Let's see. Something times something is 80. And then something plus the same one is 18. So that's going to be 10 and 8. So it's going to be x plus 10, x plus 8. So that means x equals negative 10 and x equals negative 8. So the smaller one is negative 10, and then the larger one's negative 8. All right, good job, Isaiah. So what we're going to do today, we're going to just do this intro, this one assignment, and I also want you to watch the video that's called Solving Quadratics by Factoring Leading Coefficient. And then you could actually get a different tutorial, like different way to look at it, and you decide which one works best for you, okay? Whether it's the way I'm doing it here or the other way. And then use it as you can. And tomorrow we'll do together the next assignment. By the way, if you graph these on Desmos, the x-intercepts are the answers. So you can also check your answers too. You can just graph it, and you don't really need the comma zero. All you would need is the x-intercepts. Like this one would be. If I were to graph this, right? I want you to visualize it too. So x squared. Now you don't want to just graph it because I will be grading your work on these eventually. 18x plus 80. And see, these are my two answers. All right, guys, so make sure to do this one and then the video, okay? So basically one right below it. Take notes on the video, and I'll post that as an assignment so that you can get some credit for that. Does anybody have any questions on this? I know it's a little tricky. Wednesday.
Mr. Quinones?
Yeah.
I just got one. It's like adds up to 1 but multiplies to negative 42.
Well, 6 and 7 add up, multiply to 42, and if you subtract 6 and 7, you can get a 1,
Oh, yeah.
Does that make sense? So by the way, when the numbers add up to 1, that means the two numbers are like 1 apart from each other, right? Does that make sense? Now, if it adds up to negative 1, that means the bigger one has to be negative, right? The negative 7. Don't forget the actual answers will be opposite of those, right? Because they're, it's really x plus whatever, and then the last step is you have to put them in the right spot, right? You got to put the bigger negative and the smaller, if there's two negatives. And anybody else have any questions? I'm really glad to help. So we're going to do notes.
So it's just Desmos and then watching another video?
Yeah, was just this one Khan Academy, right? Try to get 3 or 4 in a row. And then I do want to see those notes on the next video because I want you to see another way. I want you to see how Sal Khan explains it. And remember, he graduated from Harvard, so he's really smart, right? And I want you to see both approaches and see which one works for you. Okay. And then lastly, and that's it. And then tomorrow we'll do the next one. Okay, I'll even take it off the thing. So let's see, Khan Academy notes, video, and one Khan Academy.
I already did the next one.
Good job. Okay. All right. So tomorrow, sign in tomorrow because I'll probably just add one more thing tomorrow. Sorry, but I'll keep that as part of the assignment for tomorrow, Nathan. All right. I'll probably join it with like graphing so that I can combine the two. All right. Have a good day, Nathan. I think you'll be logging out now. All right.
Bye.
All right. Thank you.
Yeah, I guess I should
Bye,
probably
Mr.
go.
Quinones.
Bye.
Yeah, I should probably go ahead and get out of here myself.
Yeah. Don't forget to try to get the 3 or 4 in a row today if you can, or even if tomorrow's fine.
All right.
All right.
See you, Mr. Diaz.
All right. Bye, guys.